So we talk a lot about energy, and especially thermal kinetic energy, or heat. One of the ways that we have to control where thermal kinetic energy goes is insulation. In this model of a wall, you can see lots of different types and areas where we use insulation to help keep thermal kinetic energy where we want it. And that's outside in the summertime and inside in the wintertime. This might surprise some of you. In this window, there is also insulation. These windows are double-paned, which means they have two panes of glass that are separated, and that layer of air in between those panes of glass acts as insulation and slows down the thermal kinetic energy. So we've got an example of cellulose insulation in the wall. That's the same cellulose insulation that if you saw the Melt-A-Penny video, Tim was using. And we've got foam insulation, and also more commonly found is fiberglass insulation. There's also foam board insulation up here in the header above the window. And we also have some spray foam insulation right here by the dryer vent, the electrical wire penetrations, and the plumbing penetrations. And that does two important jobs. It helps slow down thermal kinetic energy, which we know all insulation does, and it also helps stop air leaks. This is an example of foam board insulation that is behind the siding on houses. All of these types of insulation, no matter where they are, help keep that thermal kinetic energy where we want it. Inside in the wintertime and outside in the summertime.
Hello guys, we're going to do a demonstration here today. We're going to talk about insulation, and today we're going to use an insulation called cellulose. And if you look at it really close, you all kind of see the colors and stuff in it, and you're like, well, that looks like newspaper. Well, that's exactly what it is. It's recycled paper. Newspaper and other material they throw into your recycle bin that you have at your schools, and once you throw that in your bin, they sell it to a company and they make cellulose out of it. And today we're going to show you an experiment. We're going to tell you, we talk about cellulose, we talk about insulation. You put it in your walls and your attics to keep heat in. So what we're going to do today is show you how efficient this cellulose is by taking a penny, it's a piece of metal, and we're going to set it right here on top of this paper cellulose. And we're going to see how efficient this cellulose is. And yes, we're going to use this torch. And this torch is going to go directly on this penny. And you're going to see this insulation does not catch on fire. You're going to put it right on top of that penny, and it's going to melt that penny, and we're going to drop that penny out, and it's going to be a liquid metal. And as you can see, it does not catch on fire. It smolders a little bit, but it doesn't catch on fire. My hand is not getting hot by any means. It's still on there. As you can all see, the penny is taking the heat. The insulation is not catching on fire, and there the penny melts and rolls right off and splats down. Here, I'll hold this up for you guys to see the penny. How the hot penny there, and the insulation did not catch on fire. And let's look at my hand. Let's see if my hand was insulated by the insulation. As you can see in the video there, my hands are still the same temperature. So if you have this insulation in your walls, it'd be doing the same thing by keeping your walls nice and in room nice and warm, keeping the heat in the air and the heat in and cool in.
So we have with us today a small electric water heater that would be about the size to run a small trailer. And we're going to talk about a few of the things that you could do to make this more energy efficient, save you money so you're using less energy and helping out the power plant. The first thing we can do is we could install a fiberglass water heater jacket. And what you would do is you would cut it to size, wrap it around the water heater, and what this is going to do is slow down the radiation and the conduction of the thermal kinetic energy inside of the water from getting into your utility closet or a space where it doesn't belong. One other area we can focus on is the hot water line. A lot of people might not realize this, but the hot water line can be 120 to 130 degrees Fahrenheit. So what we can do to help us be more energy efficient is take some foam pipe wrap that we can get from any hardware store, cut it to size, and install it around the hot water line. And once again, what this is going to do is help us be more energy efficient as a community, and it will also save you money in your household.